Chapter 14, Temperature and Heat Transfer. This lecture will help you understand heat and thermodynamics. Thermodynamics is essentially the study of the internal motions of systems, what we generally refer to as heat. Knowledge of thermodynamics is required to design any device involving the interchange between heat and work, or the conversion of material to produce heat, such as combustion. Thermodynamics is the study of the relationship between work, heat, and energy. Thermodynamics also deals with the conversion of energy from one form to another and the interaction of a system and its surroundings. While the temperature of the sparks in a sparkler are very high, around 2000 degrees Celsius, and there is a lot of energy per molecule of the spark, the thermal energy in a sparkler is very low. The total energy is small due to the relatively few molecules per spark, so there is a low transfer of energy. Heat is defined as a flow of thermal energy due to a temperature difference. The natural direction of heat flow is from higher temperature substance to a lower temperature substance. When a hole is drilled in a metal block, it becomes very hot. As the drill does mechanical work on the metal, the temperature of the metal increases. The temperature is related to kinetic energy. At high temperatures, the atoms in the metal vibrate more rapidly than at low temperatures. To raise the temperature of a material, we must speed up the atoms. That is, we must add energy to them. Heat is a form of internal kinetic and potential energy contained in an object associated with the motion of its atoms or molecules, and may be transferred from an object at higher temperature to one at lower temperatures. As the drill turns, it collides with atoms of the metal, causing them to speed up. This mechanical work done on the metal has caused an increase in the energy of the atoms. For this reason, any friction between two surfaces results in a temperature rise of the material. The pot of water on the left has 1 liter, and the pot on the right has 3 liters of water. Both pots absorb the same quantity of heat. The temperature increases 3 times as much in the pot with the smaller amount of water. The different masses have a different rate of absorption of heat. When the same amount of heat is added to each of the 2 containers of water, the temperature increase in each will A, be the same, B, depend on the amount of water in each, C, be greater for the container with the most water, D, be less for the container with the smallest amount of water. Answer is B, depend on the amount of water in each. Later, we will learn that when heat is added to boiling water, temperature won't increase at all. Heat is energy in transit, measured in units of energy. Joules are calories. A calorie, with a lowercase c, is defined as the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. The mechanical equivalent of heat is 4.19 joules, which is equivalent to 1 calorie. 4.19 joules of heat will change the temperature of 1 gram of water by 1 degree Celsius. The energy rating of food or fuel is the calorie. It is a measure of the energy released when food is metabolized. A food calorie is equivalent to 1 kilocalorie, or 4,190 joules, and is used as the heat unit in labeling food. 1 kilocalorie is the heat needed to change the temperature of 1 kilogram of water by 1 degree Celsius. 1 kilocalorie is the same amount of energy released by a 5 kilogram mass falling 85.5 meters. The British thermal unit, or BTU, is the amount of heat energy needed to raise 1 pound of water by 1 degree Fahrenheit. 1 BTU is equivalent to 778 foot-pounds of work. The quantity of heat needed to raise the temperature of a certain substance a specific amount is 1 calorie. This is the same amount of energy as A, 1,000 calories, B, 4.19 kilojoules, C, both of these, D, neither of these. Answer is C, both of these. 1 calorie is also called a large calorie or food calorie. 1 large calorie equals 1,000 small calories. You heat a half cup of tea and its temperature rises by 8 degrees Celsius. How much will the temperature rise if you add the same amount of heat to a full cup of tea? 0 degrees Celsius, 2 degrees Celsius, 4 degrees Celsius, or 8 degrees Celsius? Answer is C, 4 degrees Celsius. The same amount of heat is distributed to twice as much tea, so the temperature rise will be half as much.